Good day everyone, it's me Mabel Mlala from Section R and I'm going to discuss to you the plate number 14.
So once again, good day everyone. In this video, we are going to look at applying force method to solve system of all trusses and frames. So we all know that force method can be used as a method of solving statistically indeterminate structures. We have here a truss, this one, with a continuous support. It has a pin support at joint A, ruler support at point C, and another ruler support at point E. We are asked to analyze this truss. Its vertical members has a cross-sectional area of 0.006 m squared and diagonal member is 0.005 m squared and a horizontal member is 0.0065 m squared. For the value of modulus of elasticity of this truss, we have 2 times 10 to the power of 8 kilopascal. By using the force method in analyzing a truss, the first step to do is we need to find the degree of indeterminacy in a truss and select an equal number of redundant force para di ta maglisod og solve kung diri nato ibutang ang atong redundant force. By the equation of equilibrium, we notice in the structure that it is externally indeterminate at 1 degree. Why? Because due to the extra member of bar structure. And after that, we need to analyze structure with real loads present but redundant reactions removed. Here, this one. This is our free body diagram for real loads with a downward direction for Cy and the delta C. So to determine the value of bar forces due to real loads of the truss, we need to use the joint method. We need to find first the value of the remaining reactions, which is the EY and the AX and AY for the point pin support at A. So we have here the reaction value of AY, which is equal to 22.5 kilonewton in upward direction, and AX equals to 0 since there is no other reaction that will contradict to AX. And for AY, we have 17.5 kilonewton. By the joint method, we obtain the value of EH and ED at joint E. Take note that if it is in negative value, then it is a compression, and if it is in positive, then it is tension or tensile force. So the same process will do for joint A, H, T, F, and B. This one. Next is we need to analyze structure, but this time 1 unit load will be applied in the location of redundant and real loads now will be removed. So this is our free body diagram with 1 unit load applied with an upward direction for reaction Cy and for Cc. This is our one unit load applied and our upward direction for 4cc. The process is just the same with the real loadings upon determining its member, but the difference is that in the free body diagram of real loadings, which is this, the value of Cy is still unknown, whereas in this free body diagram, the value of Cy is being applied by 1 unit load. By joint method, we obtain the value of each members of the truss and, again, compression if it is in negative and tension or tensile force if it is in positive. So here is our solution for the bar forces due to applied 1 unit load. Now, our value of EY here, AX and AY, which is the remaining reactions, is changed. Its value has changed into negative and its direction is downward. So these are the values we obtained in each joint. So this is now our tabulated form of the values we obtained in solving the members of the truss. We have the members of the truss, we have the pair of unit load, the real loads, the length of the bar member, and the final force. Summation of delta C here is still unknown, as well as the summation of 4cc. We did not put AE yet because the horizontal, vertical, and diagonal members has different values of cross-sectional area. In the principle of the force method, displacement Cc has an equivalent value of 4cc Fcy. That's why it became to this equation instead of using this. And then we have a separated summation of horizontal, vertical, and diagonal members of the truss in order to obtain the value of delta C. So we have the summation of horizontal members negative 40 over EA and a cross-sectional area of 0.0065 m squared. And for the summation of vertical members with the value of negative 80 over AE with a cross-sectional area of 0.006 m squared. And then for the diagonal members of negative 125.03 with a cross-sectional area of 0.005 m squared. After that, we obtain the value of the delta C by the virtual work method formula. And this another summation is for the 4cc. We have the summation of horizontal members, which is equal to 1.5 over AE, and summation of vertical members equals to 6 over AE, and the diagonal members equals to 5.6 AE, and we obtain the value of 4cc as 1.175384615 times 10 to the power of negative 5 by the virtual work method. Now we have to balance the deformation to solve for the redundant reaction. We will use this equation to get the value of Cy. So we already get the value of delta C and 4cc. So it will be easy for us to get the value of Cy. So Cy now is equal to 18.93 kilonewton. And to check if our work is correct, let us check our work at joint E. We have the diagonal value of negative 14.56 and the horizontal value of 6.52 and the upward direction for EY, which is 13.04. And then it resulted that the summation of force horizontal has the equivalent value to the other side. The same for the summation of forces vertical, Fy. They only differ in the decimal points, maybe just by rounding off the value to the previous solution, to our previous solution, but at least they are just the same, closely the same with each other. So this time, we have to analyze the now statistically determinate structure. Going back to our first page, to our free body diagrams, if we sum up the FBD of the real loads and the FBD of the pair of unit load times its CY, for CY, we can have a final result to this truss. So we obtain the final force of the truss, which is this. So this is the end of my discussion. So I hope you learned from it. Thank you for listening, and God bless you all.